VFD means variable frequency drive. So this is one of the very practical and important circuit in the industry. So VFD in power systems. You are studying about power electronics. Now I am talking about power systems. Power system means like it is the complete system. Let's say, first of all, what is VFD? Variable frequency drive is one of the AC to AC converter. So it's converting AC source voltage into AC output voltage to the load. You are changing the frequency at the output. So VFD is one of the most used control circuit in many industries to control the speed of the AC induction motors. We will see VFD now. Example, this is just one of the several applications. This conveyor motor, conveyors. So we are using AC induction motors in conveyors or in the conveyor belts, and this is helping us to regulate the speed, or you can increase the speed or you can slow down the speed. Because of this, you can save the operational cost by speed control. Why? For example, you don't have any load here now, right? So either you can turn off or you have very minimum load. Let us take the same airport example. In the airport, the belt is not running all the time. Sometimes when the flight arrives, they put the suitcases in this kind of belt. Then the belt has to move faster because so many people are waiting. But the people are taking the load one by one. And then maybe finally, maybe just a few suitcases are there. Then it doesn't need to run that fast. So you can slow down the speed of the conveyor just by changing the frequency. And then it will consume less energy. And after take out all the suitcases, then you can just turn off. So it's really very convenient. It will help us to save a lot of energy and cost. And also it's easy to maintain, and it has a long operating life. So it means what? It means it's reliable. You can trust that motor, it can control and it can work for a long time, for many years. So that is one example, and the same applications, it's applicable in many industries. The total solution will look like this in practical application. So this is the induction motor. So you have to give the power supply to the induction motor, right? Then only the motor will run. And this is called shaft. Yes, it's not a soft drink, it's a SHAFT. It's a shaft. So this shaft is connected to the rotor inside. So this is the body, metal body. Inside the metal body, we have the stator that can be a permanent magnet, for example. Inside the stator, we have the rotor. Rotor is the one will rotating all the time. This metal rod, this shaft is connected to the rotor. So when the rotor rotates, the shaft will also rotate. Then you can use some kind of a gear wheel, the gear wheel. Yeah, something like this. So this gear wheel will be connected to this one to the load from the shaft. Okay, so you are not giving the power supply directly to this motor. What we are doing, we are giving the power supply to, this is called AC drive, VFD. So you are giving the power supply to the AC drive. AC drive is giving power supply to the motor. Then only you can control the speed of this motor. And how can you know what is going on? What is going on in this AC drive? What is the speed of this AC drive? For that, we need some kind of interface, right? This is called UI design, user interface. In a mobile phone, we have so many applications, that is user interface. In the website, we have so many browsers. These are interfaces. It's interfacing between the human and the machine. So in this interface, you will see the status of this AC drive. So what is the current frequency? What is the current voltage this is supplying to this motor? If you want to increase, you can increase. For example, now you are increasing the frequency from 50 hertz to 100 hertz. Then you will see the value here. So this is another this is called automation actually. So you can control manually, or you can set automatically. It will control the motor speed based on the load. Okay, so for that we are using the PLC. So if you want to have the automation, then you need a PLC. PLC means programmable logic controller. So you can program when the motor should be fast, when the motor should be slow. So you can program everything. What is human? Sorry, HMI. This is the human machine interface. So this one is helping us to control everything, to program this PLC. The PLC programming is a little bit different from the C programming or any other languages programming. In the PLC, you can also even using the block diagram based programming. Okay, that's a different course or field, but at least you should know the basic. PLC is helping us to have the automation in the industry, and HMI is nothing but just interface. And many companies are producing these AC drives. So it can be the ABB or it can be any other company, Unitronics or any other companies. And of course, here this UI and everything is implemented by software. And here the motor is a motor, it's a hardware. It's converting the electrical energy into mechanical energy. We are controlling the speed by using this AC drive, that is the power converter circuit. This is the one we are studying in this course, this one. So this is the one converting AC to AC, because we are applying the AC voltage and we are also getting the AC from the output, but the frequency is different. Let's see what is inside this box. Before that, example specifications. Example specifications, you can see here each company, they produce different models of AC drives. Each model have its own ratings. So what kind of input voltage it can accept and what kind of output voltage it can provide. So for example, here you have the single phase input voltage, or you can also apply three-phase input voltage. And similarly, this model can support 3 different types, and this model can support 3 different types. And input frequency, it can accept either 50 Hertz or 60 Hertz, because the companies like Ultronics or ABB, they produce AC drive. They want to sell it all over the world. They want to sell it in Norway, they want to sell it in India, they want to sell it in China, or they want to sell it in America. But for example, in USA, they are using 60 Hertz. So they need to have some kind of tolerance in their product. That is why they also have this one. For example, this motor you cannot use in USA, because here we have a 200 to 240 volt is the operating voltage. In USA, the voltage is 120 volt. So they also produce specific product for specific region. For example, maybe these motors are for Europe region. And what kind of motors it can support? Asynchronous induction motor, 3-phase input. And this model can be supporting asynchronous synchronous motor, 3-phase input. So you can see everything else here, and also you can vary the frequency from 0 Hertz to 400 Hertz. And overload capacity, so how long, what is the overload capacity of the motor, and things like that. So if you want to buy this kind of machine for any application, you have to be very specific about, you have to go through the specification, and then you have to select which one you want to buy. So variable frequency drive is also known as inverter, variable speed drive, or frequency changer, cycle changer. In different books or in different industry, they call with a different name, but everything is just indicating the VFD. So VFD can be used to control both the speed and the torque of a standard 3-phase induction motor. It varies both the frequency and magnitude or amplitude of the AC waveform being delivered to the motor. So it helps us to save a lot of money or cost of the electricity. So this is the basic of the VFD. And how can we construct the VFD? So what are the basic components of the VFD? So we have, of course, we have to supply the input power. This is normal in any circuit or device or machine. We have to give the input. And here in this VFD, these are the three important part. So we have the rectifier that you have studied already, and we have the filter, and we have the inverter. So these three parts are very important in VFD. So we will see the circuit now. We know rectifier means what it does. It converts AC into DC. Filter is just converting pulsating DC into pure DC. And the inverter is again converting this DC into AC. And so here is the just a block diagram. So we are applying the input voltage 50 or 60 hertz AC. And first we are giving this input to the rectifier. The rectifier is giving the DC output, and the DC output is given to inverter, and the inverter is giving variable frequency at the output, and this is given to the motor. So this, you see this box, this entire box is called VFD, variable frequency drive. Okay, now we are seeing only in the block diagram level, block diagram, because these are block, right? Block. So now we have to see in the circuit level.